Hey there! Ever wondered why the sky is blue? It's a question that has fascinated humans for centuries. Or maybe you've seen a rainbow and thought about how those vibrant colors appear so magically after a rainstorm. Science is all around us, explaining the everyday phenomena we often take for granted. It helps us understand the beauty and complexity of our world. From the food we eat to the way our bodies function, science provides fascinating explanations for the world we experience. Every meal we prepare is a small science experiment. In this journey of discovery, we'll unravel the mysteries behind some common occurrences. We'll explore the science that makes our everyday lives so interesting. Get ready to dive into the science behind a blue sky, the formation of rainbows, and the natural wonders that surround us. And even why onions make us cry. It's all part of the fascinating world of science. So, buckle up as we delve into the intriguing world of everyday science. There's so much to learn and discover. Let's embark on this adventure with open minds and a thirst for knowledge. Curiosity is the key to unlocking the secrets of our world. Remember, science is not just about complex formulas and equations. It's about understanding the world around us. It's about seeing the extraordinary in the ordinary. And who knows, maybe this exploration will spark a curiosity in you that leads to amazing discoveries of your own. The journey of science is endless and full of surprises. We often gaze at the vast expanse of the sky without giving much thought to its color. But have you ever stopped to wonder why the sky appears blue? The answer lies in a phenomenon called Rayleigh scattering. Sunlight is actually a mix of all colors. When sunlight enters the Earth's atmosphere, it collides with tiny air molecules. This scattering effect is more pronounced for shorter wavelengths of light, particularly blue. As blue light gets scattered more than other colors, it reaches our eyes from different directions, making the sky appear blue. During sunrise and sunset, however, the sunlight travels a longer path through the atmosphere. This causes the shorter blue wavelengths to scatter away, allowing the longer wavelengths like orange and red to reach our eyes, creating those vibrant hues. Rainbows, with their captivating arcs of color, have always fascinated humankind. These natural wonders are not just beautiful to look at, but they also hold a deep scientific explanation behind their formation. These stunning displays of nature's artistry occur when sunlight interacts with water droplets in the atmosphere. The process begins with the sun's rays penetrating the moisture-laden air. The formation of a rainbow is a beautiful interplay of refraction, dispersion, and reflection of light. Each of these steps contributes to the final, mesmerizing arc of colors we see. When sunlight enters a water droplet, it slows down and bends, a phenomenon called refraction. This bending of light is the first step in the creation of a rainbow. Since different colors of light have different wavelengths, they bend at slightly different angles. This slight variation in bending causes the light to spread out into its constituent colors. This separation of colors is called dispersion. Dispersion is what gives a rainbow its characteristic spectrum of colors. The separated colors then reflect off the back of the water droplet and emerge again. This reflection is crucial in reinforcing the separation of colors. This reflection reinforces the separation of colors, creating the distinct bands of the rainbow. The result is a vivid display of colors that arc across the sky. The order of colors in a rainbow is always the same: red, orange, yellow, green, blue, indigo, and violet. This sequence is due to the consistent way light bends and disperses. This is because red light bends the least and violet light bends the most. The varying degrees of bending ensure that each color appears in a specific order, creating the beautiful spectrum we admire. Onions, a staple in many cuisines, have a peculiar effect on us. They make us cry. This tear-jerking phenomenon is due to the presence of sulfur compounds within the onion cells. When you cut an onion, you break open these cells, releasing these volatile sulfur compounds into the air. These sulfur compounds react with the moisture in your eyes to form sulfuric acid. The sulfuric acid irritates the nerve endings in your eyes, triggering a burning sensation. Your eyes then produce tears to wash away the irritant. Interestingly, different varieties of onions have varying concentrations of these sulfur compounds. Sweeter onions generally have lower concentrations, while more pungent onions have higher concentrations, explaining why some onions make you cry more than others. Section 5. The chemistry of toast. Toast, a breakfast favorite, undergoes a fascinating chemical transformation when exposed to heat. The browning of bread is a result of the Maillard reaction, a complex chemical reaction between amino acids and reducing sugars. When bread is heated, the amino acids and sugars in the bread react, producing a cascade of new molecules that give toast its characteristic brown color, crispy texture, and roasted flavor. The Maillard reaction is responsible for the flavor and aroma of many other cooked foods as well, including roasted coffee beans, seared meats, and baked goods. It's a prime example of how chemistry plays a crucial role in our culinary experiences. Section 6. The buoyancy of ice. Ice, the solid form of water, exhibits a unique property that sets it apart from most other substances. It floats. This peculiar behavior is due to the molecular structure of ice. In liquid water, water molecules are constantly moving and interacting with each other through hydrogen bonds. As water freezes, the molecules slow down and arrange themselves in a hexagonal lattice structure. This hexagonal lattice structure creates empty spaces between the water molecules, making ice less dense than liquid water. Since ice is less dense than water, it floats on top. This property of ice has significant implications for aquatic life, as it allows bodies of water to freeze from the top down, providing a habitat for organisms below the ice layer. Section 7. Static electricity and hair-raising experiences. We've all experienced static electricity, whether it's the feeling of a tiny shock after walking across a carpeted room or seeing our hair stand on end. It's a common phenomenon that can be both fascinating and a bit startling. Static electricity is a buildup of electric charge on the surface of an object. This charge can accumulate due to various reasons, such as friction, pressure, or even temperature changes. When two materials rub against each other, electrons can transfer from one material to the other. This transfer of electrons is what creates the imbalance of charges. The material that gains electrons becomes negatively charged, while the material that loses electrons becomes positively charged. This difference in charge is what leads to the static electricity effects we observe. Hair standing on end is a classic example of static electricity. This happens because the individual strands of hair become similarly charged and repel each other. When you rub a balloon on your hair, electrons transfer from your hair to the balloon, giving the balloon a negative charge and your hair a positive charge. This simple experiment is a great way to visualize how static electricity works. Since like charges repel, the individual strands of hair try to get as far away from each other as possible, causing them to stand on end. This repulsion is a clear demonstration of the principles of static electricity in action. Section 8. Popping ears and altitude changes. Have you ever noticed your ears popping when you're on an airplane or driving up a mountain? This sensation is related to the change in air pressure. Our ears have a small air-filled chamber behind the eardrum called the middle ear. The eustachian tube connects the middle ear to the back of the throat and helps equalize the pressure between the middle ear and the surrounding environment. When there's a sudden change in altitude, the air pressure outside the ear changes rapidly. This pressure difference can cause the eardrum to bulge inward or outward, leading to discomfort and a popping or clicking sensation. Yawning, swallowing, or chewing gum can help open up the eustachian tubes, allowing air to flow in or out of the middle ear, equalizing the pressure. Section 9. Wrinkled fingers, an evolutionary advantage. We've all experienced the curious phenomenon of our fingers wrinkling after spending some time in water. While often perceived as a simple reaction to water, this wrinkling actually serves an evolutionary purpose. Scientists believe that wrinkled fingers provide better grip in wet conditions. The wrinkles act like treads on a tire, increasing the surface area of our fingertips and enhancing our ability to grasp wet objects. This adaptation would have been particularly advantageous for our ancestors, who relied on their hands for foraging for food and tools in wet environments. The enhanced grip provided by wrinkled fingers would have improved their chances of survival. Section 10. Curiosity, the key to unlocking the wonders of science. As we've journeyed through the explanations behind these everyday phenomena, one key takeaway emerges. Science is everywhere. From the sky above to the way our bodies react, science offers a lens through which we can better understand the world around us. The most important thing is to never stop questioning. Curiosity is the driving force behind scientific discovery. When we approach the world with a sense of wonder and a thirst for knowledge, we open ourselves up to a universe of fascinating explanations. So the next time you encounter something that piques your curiosity, don't shy away from asking why. Embrace the joy of exploration and remember the world is full of wonders waiting to be uncovered.